Hi, this is going to be a video on questions 7, 8, and 9. A lot of students are still struggling with this idea of how to graph an absolute value and what it means exactly. So pay close attention to this and make sure you add good notes to your work there. Here we go. First of all, we have an absolute value here. There are no numbers in there with x, there's no numbers after that. So this one has a vertex at 0, 0. However, there's a number in front. That's going to be our slope number. So anyway, no movement of the vertex. So first of all, the absolute value is going to have a vertex right there at the origin, 0, 0. Now this 2, the number in front is always your slope. So this absolute value, both directions, has a slope of up 2 over 1, up 2 over 1, and going in the negative direction as well, up 2 over 1, up 2 over 1. We end up with the big V, absolute value graph. Alright, so that's this part graphed. On the other side of the equation, we have a 4. So what this equation is saying is this absolute value is equal to this line here, and that's line y equals 4. Let's see if that line appears here. There it is, y equals 4. So now we have this absolute value and this line graphed together. And this statement says equal. So your question here is, when is this absolute value equal to this line? When are these two things equal to each other? They are equal to each other when they meet, when they intersect. So equal means they're looking for that point and that point. Those are our two solutions. That's when these two graphs are equal, means they're at the same place. They're at the equal place, same place. So there it is. Our two answers are, looks like -2, so x is -2, and +2, x is +2. So from the graph we can see that we've solved when they're equal, when they're intersecting. So now let's solve it algebraically and confirm we have the same answer. So here it is. Whenever solving absolute value, you always need the absolute value by itself. There can't be all these numbers around it. So there's a 2 here, we're going to divide by 2 first. So I divide by 2 and I got the absolute value of x equals 2. Now for absolute values, as you know, if you're going to put some numbers into there for x, the only way to get an answer of 2 is to put in a +2, because if you put a +2, that would be the answer. You could also put in a -2 into there, a -2, because that will come out as +2 also. So important step when solving absolute values is always to take this and change it into regular equations, but there's always going to be two of them. And in this case we have x equals 2, or another solution for x is x equals -2, because both 2 and -2 can go in here and produce a 2. So there's our two answers, and that matches our graph. We found out right here, -2 and 2. Those were our two answers in the graph. Number 8, similar kind of problem, but now we have a less than symbol here, and the absolute value is a little bit different as well. Whatever values you see inside the absolute value with the x tell us about a horizontal translation that's going to take place. Here we see x -3, so we're actually going to do the opposite. It's always the opposite. We're going to move 3 not to the negative direction, but 3 to the positive direction. So the vertex of this absolute value moves to the right. So the absolute value will be right here. It moves from here, it went 1, 2, 3 units, the vertex. And there's no other number here behind here, so we don't move it up or down, we just move it to the right. Now, this absolute value, which we have just graphed, has a slope of 1, because there's a 1 here that we don't see. So let's confirm. Rise 1 over 1, rise 1 over 1, yep. Rise 1 over 1, 1, 1, 1 over 1. So 1 over 1 is our slope. Great. Now we have the absolute value graphed. But on the other side here of this inequality, we have 2. That means we're looking for the line y equals 2. Let's see if that line appears. There it is. Y equals 2. Alright, so we have the absolute value, we have the line. Now we have to figure out where is it that we're looking for the solution. In this case, I see a less than symbol. So to read this absolute value, you read it as, when is this absolute value less than this line at y equals 2? And when you say it about graphs, when is it less than this? When is this absolute value below this line? So look at your absolute value here. When is that graph below the line? So here's the line. When is the big V below here? Only time the V is below. Let's follow the line. Let's follow the absolute value. Right now, where the mouse is. That thing is above the line, so that's no good. I'm still above the line. 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 And at this point, I'm right on the line. Now I'm going to keep following the absolute value. Ooh, the absolute value, I'm below the line. I'm below the line. I'm below the line. I keep going. I'm still below the line. I'm below the line. I'm below the line. I am below the line. I am below the line. Oh, I'm on the line. Now I'm above the line. So when is this below? From here to here. In this zone from here to here, the absolute value is below this line. So it's below, all right? So it's from x equals 1 all the way to x equals 5. In this zone, it's below. So our solution is going to be from 1 to 5 on the x, right? That's when it's below the line. Let's take a look. Algebraically, I write it out. This has no numbers in front or behind, so it's ready to go. Whenever you have an absolute value that looks like this, where it says less than 2, it means you're looking for a distance of less than 2. So, and you think of it as your vertex here. So here's your vertex. Here's a distance of 2 in this direction. Here's a distance of 2 in this direction. And we're looking for distances less than 2. So we're looking for exactly what we saw in the graph. The distances from the center of the graph here that are in between here, they're less than 2 away in either direction. So whenever you see this, again, this, you turn it into this. The absolute value is gone. We have always two situations, right? The positive side and the negative side. So this is less than 2, but this is also greater than negative 2 because you're looking for values between 0 and negative 2. All right, so whenever you see the inequality this way and the absolute value, it's always going to create this and situation. Let's solve that. Add 3 on both sides. 1, 5, and that matches our answer in the graph. Let's take a look. X goes from 1 to 5. X is greater than 1, but less than 5. It's an AND situation. AND means just one zone, like an overlap, right? So we're right in here. X is between 1 and 5. Let's look at number 9. Number 9, again, we have an absolute value. This time there's a number right here. This number is not inside, it is outside here. That means it's going to be a translation on the y-axis, and this is -2, so we're going to go -2. So our absolute value, instead of starting here, it's down 2 units right here, -2. All right. Now the absolute value, again, like the last one, we don't see it, but there's a 1 in front here, so the slope is 1. So rise 1 over 1, rise 1 over 1, rise 1 over 1. Both ways, slope is 1. All right. And our line is 1, so I put y equals 1 right there. Y equals 1. That line has been graphed now. So now look at this again. What is this saying? This absolute value is greater than or equal to this line. So when is this absolute value greater than this line? When is this absolute value above this line? So let's start here. I'm following the absolute value. Oh wow, over here, it's above that line. Okay, it's above the line, it's above the line, it's on the line. Now it's below the line, below the line, below the line, below the line, below. It's on the line. It is above the line over here. So again, we're looking for above the line. So this time, I'm going to put the same lines there, but the solution is not the middle part now. It's this part and this part, because over here, the absolute value is above this line. And over here, the absolute value is above this line. So our solution is over here and over here. So x values, this is -3, x values is less than -3, and x values greater than 3. Okay, let's solve it and confirm we get that. Again, you cannot do anything until you have the absolute value by itself. So there's a -2 here. I'm going to add -2 on the other side, like this. Now I have a simple statement with the absolute value and a number, so I can rewrite this as 2 parts. Whenever we have the inequality facing the absolute value like that, this is saying the distance from the center is greater than 3 units away. So again, here's the center, here's this is 3 units away. We're looking for values that are greater than 3 units away, so over here. And then it's like a mirror image on this side, then we're looking for values that are more than negative 3 over here. So this becomes this or this. Okay, so important to see when this is facing this way, we write this, we write or, and then we do x less than negative 3. See how these numbers, x is greater than 3, think of those numbers, 4, 5, 6, 7, all those numbers. And we need to do a mirror image of that. So we're looking for negative numbers that mirror these, 4, 5, 6, and so on. Over on the negative side will be negative 4, negative 5, negative 6. It's like a mirror image. So these values must be less than negative 3. So pause if you need to really understand that right there, why this is written this way. And those answers match our graph. X is greater than 3 and equal to it, or less than negative 3 in that right direction there.